Math 1332, Chapter 7, Consumer Mathematics, Section 1, Percents, Video 7, Percent Change Problems. A lot of times, percents are used to describe how much a value increases or decreases. For example, maybe you are going to get a 5% pay raise, or maybe you're going to lower the price on something by 15%, or maybe the price was lowered and you want to know by what percent did the price decrease, or maybe your salary went up and you want to know what percent did it increase. So a percent change problem is, there's two ways to do it. I can tell you the percent to change and then you can change the value, or you can change the value and then calculate the percent change. In the previous video, when we did the 15% discount on the refrigerator at one of the stores, we calculated the percent change by calculating 15% and then subtracting it to create the change in the price. But if the change has already occurred, then we can flip that and say, well, what percent did it change? And it may sound like it's a pretty straightforward problem, and it essentially is. But there is one thing you got to be a little careful with, and I'll explain where most people make a mistake here. How to calculate percent change. Suppose the number changes from an original value to a new value. So it was one value and then it changed to something else. To calculate the percent change, use the following formula. Percent change equals the new value minus the original value. In other words, I wanted that to be yellow. In other words, how much did the value change? Then you divide that by the original value, and this is where most people make a mistake. If they make a mistake, they'll figure out how much it changed, but then they'll compare it to the new current value instead of the original value. When you calculate a percent change, you are always comparing how much it changed to how much the value was before it changed, the original change. And then to turn it into a percent, you simply have to multiply by 100%. This is essentially to say move the decimal two places to the right, and then put on the percent sign. So don't let that part throw you off. I do need to point something out though, that the subtraction problem on the top might come out negative. For example, if the price of something goes down, then the new value is less than the original value, and so new minus original would be a negative number. But that's okay when that happens. When it does, it means the value decreased. When you're describing a percent decrease, we don't say the negative sign, we just say percent decrease. For example, if we got an answer that was negative 15%, then we would say that it was a 15% decrease in price, not a negative 15% decrease in price. You would actually be saying a negative twice there and making it positive, so let's not do that. Let's take a look at a couple of examples. Example 1. A city government promised a 12% cut in spending for the next fiscal year. The city's budget was $70.5 million this past year. The projected budget for the upcoming year is $61.4 million. Did they keep their promise? Explain. Now, there's a couple of ways to approach this. One is to figure out what's 12% of the last year's budget. Subtract that from last year's budget to see if it's the current year's budget. Or we can calculate how much the budget changed and calculate the percent. To use the formula on the previous slide, we are going to do the latter. We're going to calculate the percent change. All right, so let's start by figuring out our players here. Our original value was $70.5 million. And our new value is $61.4 million. So this is the original, and this is the new. Now you may be wondering, what do I have to do with the word million? Do I need to actually write something like 61,400,000, which is what you would get if you multiplied 61.4 times 1 million? You could do that, but it's not really necessary if you think of million as just a unit of measurement. For example, if we said $61.4 or 61.4 gallons or 61.4 millions of dollars, those are all just measuring units of measurement. The important thing is that the original value and the new value are in the same unit of measurement. And if they are, then you can just leave them that way. So what that means here is when we do the math, we can just use 70.5 and 61.4. We're just measuring millions of dollars instead of single dollars. All right, so how would we set up the equation? Well, you start out with the new value, which is 61.4, minus the original value, 70.5. And then you compare that to the original. This is where most people make a mistake. Don't put the 61.4. We have to compare it to what it was before it changed. We have to compare it to 70.5. Just remember, these two numbers will always match. And then we're going to multiply that by 100%. All right, let's see what happens if we do 61.4 divided by 70.5. Now, there's something I need to warn you about, especially if you're using a calculator. If you type in exactly what you see, forget the percent for a second. We'll put that back in a moment. If you type in exactly what you see, if you type in your calculator 61.4 minus 70.5, and then division, fraction is division, divided by 70.5, it will give you the incorrect answer every time. Why? Because your calculator probably knows the order of operations. The order of operations, please excuse my dear Aunt Sally, basically says you're going to divide before you subtract. It would do this division problem and then subtract its answer from 61.4. Well, the answer to that division problem is 1. And so 61.4 minus 1 is 60.4. But the way the problem is set up, we don't do the division first. The way the problem is set up, we do the subtraction first. This isn't said in a lot of classes, but when you have an addition or subtraction problem inside of a fraction like we do here, it's almost like there are some parentheses around it saying you have to do that first. And what that means is when you type this in a calculator, unless your calculator allows you to type a fraction vertically, where you can make sure the subtraction problem is entirely in the numerator, if you're typing it out left to right like I'm about to do, then you have to type parentheses around the subtraction problem, or at the very least complete the subtraction problem before you divide. I can actually illustrate this using the calculator on the computer, which I'm about to share with you. All right, you should be able to see that now. All right, so what were our numbers? I forgot. Our numbers were, well, shoot, I have to go back here just for a second because I wasn't paying attention. 70.5 and 61.4. All right, 70.5. If we did and 61.4, watch what happens. If I do 61.4 minus 70.5 divided by, it already did the subtraction, which I didn't expect it to do. Okay, I just learned something about this particular calculator. It doesn't know the order of operations. So let's pretend that didn't happen, and let's clear all this out. Oh, wait. Yeah. If you have a scientific calculator, which is what you probably have, if your calculator has parentheses and a bunch of buttons that you don't know how to use, or that you don't need to use, like sine, cosine, and tangent, then you have a scientific calculator and it knows the order of operations. So watch what happens when I try to do 61.4 minus 70.5 divided by 70.5 without using parentheses. You see it typed a problem up there, but it didn't do the subtraction first, it did the division first. You can tell because the answer to this division problem is 1, and 1 from 61.4 is 60.4. Instead, if I want to trump the order of operations, that's what parentheses are for. So instead, I'm going to type parentheses 61.4 minus 70.5, close parentheses, divided by 70.5. And now it knows to do the subtraction before the division. All right, so it is your responsibility to know how to use your calculator. If you're not sure, get a hold of me and I'll be more than happy to help you out. All right, let's go back to the problem at hand, if I can get this to cooperate. All right, so anyway, make sure you know how to put it in your calculator correctly. If we do that, we end up getting, I just had it there, where did it go? We're going to round it to 3 decimal places just because I chose that. Negative 0.129. Negative 0.129. Now, do they keep their promise? Well, first we have to know what percent this is. And because it's negative, that means it's a percent decrease. So let's go ahead and just answer what the percent decrease is. I don't want that yellow, really. There we go. All right. The budget decreased by 12.9%. And notice I didn't type the negative because I said the word decreased. The budget decreased by 12.9%. So, did the city keep their promise? Well, you could argue no because they said 12% and it's 12.9, but let's look at it from a realistic perspective. You're a voter, you voted for them, they said we're going to cut it by 12%, and they cut it by 12.9%. Are you happy? Did they keep the promise? Of course they did. We cut it by 12% and even more. So the city kept their promise because it was a 12.9% decrease in the budget. All right, let's take a look at one more, example 2. Because business is booming, the CEO of a company promises all of the employees at least an 8% increase in pay. One employee's hourly wage increases from $16.25 to $17.75. Calculate the percent increase in the hourly wage. Did the CEO keep his promise to this particular employee? All right, if we're going to calculate the percent increase, we need to locate the original value and the new value of this employee's hourly wage. The original value, his hourly wage before he got the pay raise, was $16.25. The new value after the raise is $17.75. So the percent change is going to be the new value, $17.75, minus the original value, $16.25, and that difference is compared to the original, $16.25. Let's see, he got a $1.50 pay raise, didn't he? He did. And if we divide that by 16.25, here I actually wrote the answer to the subtraction problem first because I could. That's actually not a bad idea to write the answer to the subtraction problem and then proceed with the division. If we divide that, we get to 3 decimal places. Again, why 3? I don't know. I just chose it out of nowhere. 0.092. The next digit is actually 3, so it didn't cause the 2 to round up. So notice it's positive, which makes sense because we had an increase in value. So our answer is it was a 9.2% increase in wage. And so the answer is yes, the promise was kept. So why didn't he calculate exactly 8%? Because maybe he just said, give him a $1.50 more an hour. All right, so to summarize, when you calculate a percent change, it's actually really straightforward. I really didn't dwell too much on the times 100% aspect of it over here. That's just a technicality. All it's saying is after you've done the subtraction problem and divided it by the original, you'll have a decimal. Move the decimal 2 places to the right, which is the same as multiplying it by 100, and stick a percent sign on it to get the percent change. The only thing you have to remember, there's 2 key things to remember. Original value is always on the bottom. That's what you divide by. And if it comes out negative, it means there was a percent decrease. But when you describe it, you don't say the negative on the number. You simply say percent decrease to imply the negative.